Hello, today we'll be talking to you about polarization. My name is Lynn MacArthur.
I'm Wesley Hawkins.
Next slide, please. So the theory behind it is basically when light comes out of a source, when it comes out of the sun, a light bulb, anything, generally it's not polarized, it's unpolarized, which means that the light and the electromagnetic waves are going every which way. They're coming out and the photons are kind of scattered, going a ton of different angles. What polarization lets you do is it takes a lens with, sometimes it's crystals, sometimes it's just polymers that are stretched. And the idea behind it is that it only lets light of a certain direction through. So you only get light with that certain electrical field going in that direction when it goes through the lens. What you can see is that if you have one lens right there, and then a second lens at the same angle as the first lens, you're going to get only light of that specific angle. But as you rotate the second lens, it's going to let less and less light through as it goes through. And the intensity of that light is going to have this equation. Intensity equals the initial intensity times the cosine squared of that angle theta between the two lenses. Can you bring up the next slide, please?
Next slide.
So, go for it.
Alright. So, this experiment has materials and procedure. The materials, as you can see, are the laser producer, the lenses, one of which is just a lens to initially polarize, and the other is to polarize with an angle, as shown by the previous equation.
So here you see the light source, the first lens, the second lens, with it's kind of shaking, but it has a dial on it to control the angle, a sensor that senses the angle that second lens is at, and then the sensor for the light intensity. So what we're doing here is we're putting light out through here. We're starting this lens at the same angle as the first lens, and then as we rotate it slowly and constantly at the same speed, you're going to see that the light intensity responds to the angle between it with that same equation that I showed you earlier of the cosine squared of the angle between the two.
Thank you, Randy.
That was Wesley.
So, when you perform the experiment, as you can see, you will get two graphs. One of which is of the cosine function generated by the equation E equals E naught times cosine theta, which should be the first one. And that is just how the cosine wave of the light is being affected by the polarization in the experiment.
And here you can see that to start, when the angle between the two lenses is at 0, you have full light intensity of at or near 800. And then as you rotate it, the light intensity dips dramatically until it goes to almost 0 as the two are perpendicular to each other. Yes, Magda?
That's because the angle is 90, no?
Yeah.
Yes.
Yeah.
And cosine of 90 is in fact 0.
Yes, thank you.
Yeah.
Good job, Wes.
The same for cosine square.
Yeah. Yeah.
And then you go past 90 and it starts going up again as it becomes realigned. And that's just repeatable as it goes through the cycle.
And this second graph of a linear variety is for the intensity. So you saw, yes, Magda?
Why is it always positive?
The intensity?
The function, yes.
Oh,
Because you're squaring it, so it's always going to be positive. Also, you can't have negative
this is true.
light intensity.
Who is a teacher?
Thank you.
That just sounds
Look at her
impossible.
face. She was doing teacher questions.
I like those questions.
Yeah, but she was
I like those questions.
for
Those are my favorite too.
teacher
All right.
Yeah. So
reasons.
as you travel along the wave in the first graph, your intensity will change because of your angle it's changing, and these two lines show that change.
And from these results, we've concluded that basically the theory that we showed you earlier, that as the two go more perpendicular to each other, the result you're going to get with intensity is just a result of the cosine squared of the angle between the two. So this experiment did a good job of proving that theorem. Thank you.
Para bien.
Very good. Very good.
There.
More questions to team two?
comments,
We unfortunately do not.
No. Can you think about any practical application of polarization?
Yeah,
Sunglasses.
Yeah,
Sunglasses. Very good.
Sunglasses, even those, what are they, like blue light glasses?
Yeah.
Why this polarization effect is good for sunglasses?
So the way that polarization works in sunglasses is it blocks out all the glare from other things. So when you have, like, for example, you have can I turn this off for a minute?
Yes.
Draw a diagram?
Yes. There is a remote somewhere.
By the mouse.
And just mute.
So pens anywhere.
There you go. On the black. Here.
Oh.
There you go.
So you have the sun, right?
Beautiful.
So you have.
That's the sun.
Hey, now.
That's
For our
It's a
purpose,
wonderful sun.
yes. You'll have to use your imagination.
Vibrating sun. It looks like what they
Be
give to us
creative.
germs. You know, like a
So you have
biology class.
a sun light, right? Sun going down from the light. Say that this is like a pond or some sort of body of water or snow that you don't want glare coming from. That sun light getting reflected off the water is going back into your eyes, and that's like harsh to look at. Obviously, if you've ever seen something reflect off something else, like a car windshield or something that's irritating to look at. But what happens is when the sun hits the water and bounces back off, the sunlight rays are going out every which way, right? However, when they hit the water, they get slightly polarized. So as it comes back off the water, you're only getting them in one angle, more or less, as they enter your eye. What the sunglasses do is they take that light and
The figure is wearing the glasses now.
they filter out light of that certain reflection angle, right? So when things get reflected off, they're only in that one plane, or the electromagnetic waves are only in that one plane. So the polarized sunglass lenses allow you to filter out that, not wavelength, but that angle of reflection by having an opposite angle of reflect, or opposite polarization angle within inside the sunglass lenses. Does that make sense?
Mm-hmm.
So then that allows you to cancel out the glare coming off the water and see through it and see whatever you want to see under it without getting the glare interruption.
very good. Any other application?
Glare means reflejo, ¿no?
Destello.
Vale.
Brillos. Any other application?
Screens.
Screens.
Yeah.
Why screens?
Because they have polarized
Polarized
like,
filters.
Screen like
Mhm.
over them to do that, but the other way around to make us see it.
Exactly. So you can have a negative polarization if you wish to block light, or positive polarization to allow some light going through. Next week I will show you. I didn't. I'm just having this idea. Next week I will bring some security elements for documents based on polarization. Okay, things you can put in your banknotes, on your passport, on your ID cards, that works with polarization to see some hidden image. Okay, that's something I will bring next week. Okay, from my job.
I've also seen like at banks, a lot of the times on the computers that they have at banks, they'll have an extra polarized, not necessarily a screen, but like a plastic sheet that goes over it. So that
Exactly.
you can only see it looking in at one angle, but if you're over to the side trying to like look at someone
Exactly.
else's information, it's black.
Exactly. That's another use. Okay, you can use the polarization.
Like sunglasses, like
Yeah.
polarized glasses, and then nobody can see nothing but you that you have
Yeah,
the glasses.
that's really cool.
And another very very effective use of this is the for 3D images, for 3D shows in theater, right? For the movies, you go to 3D and you have these funny glasses with basically two colors or something, and these are based on polarization as well. Okay.
One stretched one way, one stretched
Exactly.
the other, so it overlays two different images, so you get perspective.
Exactly.
on a flash.
They were filmed with two cameras slightly deviated one from the other,
Yeah.
and your brain will we'll make we'll join both using polarization basically.
Awesome.
Very good. Very
Is
good.
it going to be in the midterm? This no.
Say it again.
Is it going to be in the midterm?
I don't know. Okay, good. Good job. Good job. Thank you very much.